Hi guys, welcome to another video. Today we are continuing with our grade 12 paper 1 preparation, and we are doing cubic functions. If you're looking for the paper that this question is from, the link is in the description. The first question asks us to show that k equals 1 for this cubic function. So this has been factorized already, meaning that these are the roots, 4 and k are the roots. So in order to show that k is equal to 1, we simply just substitute 1 into our function. And we get 1 cubed minus 6 to the 1 squared plus 9 times 1 minus 4, and that gives us 0. So therefore k is equal to 1. Okay, let's go on to the next one. Nice simple one to start. Okay, let's just clear this. F of x equals, okay, so same. Now they want us to calculate the turning points of f, right? So the turning points of this cubic function are where the derivative is equal to 0. So we have to find the derivative first. So that's going to be 3x squared minus 12x plus 9. And then we make that equal to 0. We can divide everything by 3. And we get x squared minus 4 plus 3. So then we know that it's x minus 3 and x minus 1. So our turning points, well, the x values will be 3 and 1. Now what we do is we substitute in these values to get our y, right? So that we substitute that into the original. Okay, so we put f of 1. Well, we already know that that's equal to 0. So that one we don't have to do. We just have to do the 3. So f of 3 equals 3 cubed. Let's put it in brackets because if there is a negative, it's not this time, but just get into the habit of that, because when you square the negative, it becomes positive. So if you don't use your brackets properly, then you will make a mistake. So here we get, put this in our calculator, and we get negative 4. Okay. So our turning points are 3 and negative 4 and 1 and 0. Okay, let's go on to the next one. Okay, so for this question, 9.3, let's just clear everything. We are asked for the concavity, right? So just a reminder, concavity is where you find the second derivative, right? And where it is greater than 0, you think of that as being a happy face. So it'll be concave up. If it's negative, think of it as being sad, right? So that'll be concave down, right? Sad face. All right, let's get that second derivative. And so we've got our first derivative already, which was, let's just quickly do it here. It was 3x squared minus 12x plus 9. Okay, so then our f double dash of x will be 6x minus 12. Okay, now they want to find out what it is at negative 3. So we simply sub in negative 3 into x, right? And so we will get f double dash of negative 3 is equal to 6 times negative 3 minus 12. And that gives us negative 30, right? So it is a sad face, right? It's sad, negative. So it is concave down. Concave down. Okay, now the next one Let's get to the next one, 9.3, clear all of this. Okay, we sketched the sketch F with turning points and intercept. So I've got down all the values that we got for 9.1, 9.2, and 9.3 in order to do this. Okay, so let's do 9.1, right, is our x-intercepts. Okay, so let's do that first. Okay, so we have it at 1. And remember, it's x minus 1 squared. So there's there are 2 here. So basically what it means is it touches the x-intercept at 1. It doesn't go through. And then the other one is at 4. Okay, now we got our turning points at 1 and 0 there. And then the other one at 3 and negative 4. So that would be down here, right? And negative 4. And we know that our y-intercept is going to be negative 4, right? Because when we make x 0, we get negative 4. Right? So that's how we got that one. Okay, so we can see that it's coming up from the left-hand side. I'm going to do it in, should we do it in pink? Why not? And then it's going to go up, and remember it turns here. And then it's got another turning point here at 3. This was 3 and minus 4. Let's just write that down. That's 3. I did mean to write 3. Okay, I just need to put this 4 a little bit further along, don't I? So there, we'll put our 4 there. Let's just do that. And it goes through that, right? Through that 4. Okay, and then we just put an arrow here and an arrow there. Mark our x and our y axes. And we are done. Guys, at the end of this video, I'm going to, because this was a fairly straightforward cubic function question. What I want to do though at the end of this video, if you stick around, I'm going to show you some the relationship between a cubic function and its derivative, because some of the questions are more kind of understanding, and so to help you for your exam, I'm going to go through that just to give you a better understanding of what's going on, because there was a question earlier in this paper which was kind of confusing if you don't understand really what's going on. So stick around till the end, I will show you that. But for now, let's just finish this question. Hopefully your question today will be as straightforward as this. Not that it's easy, but it's not too bad. All right, so when you want to calculate the maximum vertical distance, what you can do is between these values, the distance between them will be the one graph minus the other, right? So I just want to actually let me just show you this function quickly, because this was our function here, negative 4. So let me just draw this again. Okay, and what I want to do is just show you the derivative quickly. Okay, so I am kind of going to show you what I wanted to show you now. So the parabola, the derivative, do you see, is a happy face graph. So it goes like this. All right. Now remember that the parabola, when we found out what these values are, the intercepts, those were the turning points, right? So that we get our x-intercepts would have been at 1 and minus and at 3, because those are the turning points, right? I'll just do them in yellow. Okay. So what that means is the point of inflection is somewhere at this turning point here. Okay, now you didn't have to work it out, but if you did, you would make the double derivative equal to 0 and you'd get a point somewhere here. Now, what we notice here is this goes, look at the slope. It's going positive, 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 positive. Okay. And that makes sense because this is above the x-axis. Now it goes negative, negative, negative. It's going downwards. And that represents this part here. Below do you see that now when it's below the x-axis, that because this is the derivative being negative, it shows a negative slope, right? And then the positive above the axis here, in terms of the parabola, is where it's sloping up again. Okay, if you're not sure what's going on, stick around. I will explain this again. Okay, so what we want to do is find the distance between these two functions if I was to draw them. Okay, so what I want to do is just lightly in a dotted line, just draw what this would look like. Okay, so draw the two functions. Okay, and so it would be kind of like that, right? Where it's going down, my parabola is positive. So this, let me just line this up nicely. Okay, so it stops being negative at this point 3, right? And that's there. Okay, so what I've done in the dotted line in yellow is I've just drawn this parabola. It's not a very neat one, but that's it there. Okay, so when you want to look at the distance between these functions, we want it between 1 and 3. So we want it here. Okay, so what we're going to do is we're going to end up with 2 answers, right, for our maximum. Because it could be here. I'll do this in orange. It could be this distance here, or it could be kind of this distance here, right? So either it could be that the pink graph, the f of x, could be bigger than the, could be higher than the f dash of x. Okay. So what we want to do though is with a question like this, so you didn't have to know all that. You could have just subtract them from each other to see what value you get, right? So let's do that. So because it's the maximum. So we'll get the maximum, which is the distance between them, and then we will make that, get the derivative after that in order to calculate the distance, the maximum distance, the place where the distance is the maximum. Okay, so now I'm going to subtract my f dash of x, right? So I'm going to get 3x squared minus 12x plus 9. Okay, and what I'm left with is x cubed minus 15x, because the x's should cancel, shouldn't they? The x squared should cancel, do they? No, they don't. Oh, no, they won't cancel yet. We subtract, remember it's h of x equals between f and h of x is negative 2 f of x. So we have to put a negative 2 here. Okay, yes, there we go. So then it'll be negative. So when you subtract, it'll be negative, negative. So this will be a plus. Okay, so then, yeah, so then these will cancel. And then we'll get a negative 24 plus 9, which will be minus 15x. And then we will get our other value, it'll be negative 4 plus 18, so it'll be plus 14. Now, to find the max distance, all we need to do is find the derivative of the distance, right? Because this essentially is the distance. I'm going to say here for d of x, right? Distance. So the d dash of x is going to be where we find the maximum. We make that equal to 0. Okay, so that'll be 3x squared minus 15. And so the derivative will be 6x 0, right? Sorry, no, we've already got the derivative. So the distance now is where that's a maximum, right? So therefore, we'll make the d of x equal to 0, 3x squared minus 15. So we get, divide both, take the 15 across. So you'll get 15 equals 3x squared. Divide by 2, we'll get x squared. Divide by 3, we'll get x squared equals 5. What's going on with me today? And then we get x equals plus or minus root 5. Now, the answer is between 1 and 3, so it's not the negative value. So therefore, x is equal to the positive root 5, right? But x is not equal to the negative root 5 because of the restriction. Okay, now we know what x is. We can simply just substitute that in to our distance formula that we've already worked out, our d. Okay, so now it's going to be d of root 5. Okay, and our distance formula there is going to be root 5 cubed minus 15 root 5 minus 14. Stick that into your calculator and you get 8.36. Don't forget to say units. Okay, so that is the question there. Now what I want to do is, if you just stick around, I am going to just show you a little bit of stuff for your paper on cubic graphs. Okay, so I've got a bit of blank paper here, or should I say a blank screen here, where I just want to go through these cubic functions briefly, just to show you how the derivative relates to the cubic function. Okay, so let's do our cubic function here. I want to do this one here. Okay, now this is where x cubed, because our cubic function would be x cubed, plus x squared plus something, right? What I want to focus on is just whether it's positive or negative. So let's say that we make it sort of a huge number cubed, right? That's just a very big number, and it's positive, right? Because it's a plus cube. So basically what I'm saying is, as we go this way, our graph tends to infinity. Okay, so when you get a positive x cubed graph, it's going to look like this. Now, there is also a case where it looks like this, down here. Okay, just delete that. And I'm going to show you how you know this. And what I want to do next is, first of all, just show you what happens if it's negative x cubed times something, plus something, right? Well, then it's going to be negative that huge number cubed, right? So as this goes to infinity, it ends up going down because it's a negative, right? So our y goes down. So in that case, our function is going to look like this. Okay. So whenever you get a negative, it's going to look like this. And whenever you get a positive, it's going to look like this one. Now, why is that important? Because in the question that we did, we had a fairly straightforward cubic function question, but you could get asked something a bit more tricky, which a previous question, I think it was 5.3 in this paper, Yeah, 5.3, if you go and look at that, they ask a question which it requires you to kind of understand that, okay, so just a reminder that I didn't put that thing, but remember as x goes towards infinity, y goes downwards. So that's why it's this shape. And then you sometimes get a case where it looks like this. Now I'm going to show you why and how. Because sometimes what they'll do is they'll give you the derivative and ask you to sketch the cubic function like they did in 5.3. So let's see how that would work. Okay, so what I want to do is just first look at the slope of this function, right? So you see over here it's going up, right? So it's positive, 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 positive. Then it goes down, but then over here it goes up again. Positive, positive, positive. Okay. Now, where does it negative? Over here, over here, over here, over here, over here. So how would this look if you were just given a parabola? So if you were only given the derivative. So remember now the derivative shows you where it's negative and where it's positive. So here we see that it starts as positive. So it must be this happy face parabola. And then it goes down below over here. And then the upwards corresponds to above the x-axis. So this would be the derivative. Okay, so if this was f of x, and this would then be f dash of x. Okay. Now, what happens if we just move this parabola up above the x-axis like this? Well, now it's always positive. So if it's above the, it's always positive. And so if you are given a parabola that's a happy face above the x-axis, this is what your cubic function will look like. Okay, now when you want to get the salient point, or where it goes from concave up to concave down, you would still just get your f double dash of x and make that equal to 0, and that would give you your salient point somewhere there. And in this graph it would be somewhere there, right, where it goes from concave down to concave up, right? If I was to draw that, I would sort of say, it goes like that, and then that's concave up. Okay, getting a little bit of messy. So now if we do this one, it would be the opposite way around, right? I'm going to do it just for those of you who are still not sure. So here, do you see that it's sloping down and slopes down over there? And then here, it would slope upwards. Okay, so now this, if it was a parabola, would start at negative, and then it would go above the x-axis. So this would be a sad face parabola. So it would have a negative something x squared, right? And that makes sense because what's the derivative of negative x cubed, right? It's negative 3x squared, right? So it's negative. So that makes sense why it would be a sad face parabola like that. Okay, so if you're given a negative, a downward faced, a concave down parabola as your derivative, your cubic function looks like this. Okay, on the right. And if we were to move, so let me just draw an x-axis here, right? Well, if we were to move this down below below the axis, well, now we see that it's always negative, right? See that? Okay, let's do it in yellow because it's so I don't confuse matters. So if we move this down, you see that it's always negative. So if you shift your parabola down below the x-axis, that shows that your derivative is always negative, and so that's why, look, this is sloping down. Okay, so I just thought I'd go into that because I got a question on the 5.3 video about this, and I just thought let me just explain this. So yeah, thanks for your time if you've stuck around this long. And if these videos are helping, please like, subscribe, and all that good stuff. And I will see you in the next the next video for question 10.